Hello students, welcome back. In this video, we are going to learn about domain and range of a function. We have already learned what is a function. So let's start. Here I have given one example of a function. So f from x to y, where f of 1 is a, f of 2 is b, and f of 3 is d. This is the given function. So what is domain? The set of all x involved is domain. So function we write like this, fx is equals to y. So if you compare all x, so inside the bracket all x are there. So domain of the function is that set. It's a set which involve all the x. So 1, 2, 3. What is range? The set of all y is involved. So y is involved from here. If you compare with this one, which all y's are involved? A, B, D. Only images. So from here we can understand what is domain and what is range. Domain is written as DF. It's the largest possible domain. Range is written as RF. Or in other words, in easy way also you can remember, domain is all the elements of set X. You can say same thing, 1, 2, 3, set X has elements 1, 2, 3, and domain is also equals to this one. And range, all Y is involved, so only images. So images are A, B and C. A, B and D. C is not involved, so C we are not involving in the range set. So A, B and D, these elements form a range set. So we have now understood what is domain and range of a function. So we will learn now how to find range and domain. How to find range and domain. So there are so many ways. The first method is the graphical method. From graphs, how to find range and domain. So let's consider this first example. So in this example, we can see one graph. So this is a graph of one line, which is a continuous line. It's not breaking anywhere. You can see this one. So for finding domain, just see the x-axis. Do you see anywhere this graph is breaking corresponding to any point? X can have any value. So corresponding to this value of x, we can see we have corresponding value of y also. At every point corresponding to this value, we have this value of y. So that means for this particular function, x can have any value. That means the domain of this function is a set of real numbers. Same way for range. If you see the corresponding points on the y-axis, so same way here we can see all the points. So that means range of this function is also real number, set of real numbers. Now let's consider the next example. In next example, domain and range we will see. First of all, here we can see endpoints are there. So this dark dot means endpoints. Endpoints. So that means boundary has been set. So only the graph lies between this region. This curve is not exceeding beyond these points. So that means the range and domain, it lies within this boundary only. So for domain, we will see the curves points corresponding to x-axis. So this is the curve. If you see, I'll just write in this way. First of all, x minimum and maximum value. If you see here, so minimum value of x, this means equal also. This means dark dot means equal also. So x is equal than or greater than 1. Equal or greater than 1. So the maximum value of x is at this point. That means x is equal or less than, because beyond this point we don't see the graph. So that means x is less than or equals to 8. So this is the domain of this function. X is greater than equals to 1 and less than equals to 8. It can also be written like this. 1 to 8, closed brackets. So this square brackets you see, this we say as closed bracket. So that means the value is equal also. The value is equal. So x can be equal to 1 as well as 8. If there is no equality, then we can write like with open brackets 1/8. So like curved. But here dark dots means equal. So domain we have figured out. Now let's see range of a function. For range, we will see the points on along the y-axis. So points of the curve along. So here you can see this is the maximum and this is the minimum. So corresponding to this, you have to see maximum value of y. Maximum value of y. Range is y. So y is greater than equals to 2 and y is less than equals to 6. So this is the range of the function. We can also write y lies from 2 to 6. So this is the range of this function. Very easy. The corresponding points of the curve you have to see along x-axis for domain, along y-axis for range. Let's see the next one now. The next graph here we can see it's a curve, it's a parabola. So here again the name of the curve is parabola. We will learn it's a graph of a quadratic function. While doing quadratics, we will learn more about this graph. So this is a graph of quadratic function. The first one which we did, that was a graph of linear function. Line means linear. So we'll learn more about this while doing linear functions and quadratic functions. Now what is the domain? So here also if you see there are no endpoints. See here the dark dot means endpoints or boundary points are there. But here also that means it keeps on going. It keeps on going. So that means if you see along x-axis, so x will have all the possible values, all the possible values. So that means again, the range of this function, domain of this function, is a set of real numbers. So we can write real numbers also we can write like this, or we can write minus infinity to plus infinity. That way also we can write all negatives as well as positive numbers. So this way also we can write. And now what about domain? Domain we have done. Domain is the set of real numbers. Now let's see range of a function. Range of a function. For finding range, we have to consider the y-axis. So for this curve along y-axis, we have to see which all points are covered. So only the upper part. See y-axis is this one, upper one as well as lower one. So this is positive y-axis, this is negative points of y-axis, and this is 0, origin. So you can see it is starting from origin. So that means minimum value of y, if I see y is greater than equals to 0. It is equal also, but it is going till infinite. It is going till infinite because the graph is not stopping. It keeps on going. So that means 0 to infinity. Because of equality, I'll be writing square bracket and here open. So closed, open. This bracket is known as closed bracket and this one is open. So this is the range of the function. So you can also write as y is less than infinity and it is greater than equals to 0. This way also we can write. Now when the function is given to us in formula form means fx is equals to some formula. When the function is given to us in the formula form, that time how to find domain and range of a function. First of all, we will learn about domain. Then in next few videos, we will be learning about range as well. So graphically, both we have learned how to find range as well as domain when graphs are given. But when formulas are given to us, when function is given to us in the form of a formula, that time how to find range, first of all, we are going to learn. How to find domain. So domain we write as df. So few cases I have discussed here. So we mainly deal with the following cases. The first one, if fx is given to us in the form of a polynomial, then domain of a function is a set of real numbers. So in the form of a polynomial means here first example I have given fx is equals to 2x cube plus 3x square plus 1. So in that case, domain is always equals to set of real numbers. Like example I have given. So fx is equals to 3x minus 9. 3x minus 9 is again a formula form only. So that means the domain of this function is the set of real numbers. Let's consider the next case now. In next case, if fx is given to us in a by b form, then b cannot be 0. We know this thing. So that means in this case, domain of a function is equals to r minus roots of the equation b is equals to 0. How to find out this one? Let's see. This is the given function. This is a by b form. This is the function in the form of a by b. Now how to find its domain? So we know domain of these type of function is equals to r minus roots of the equation. Roots means solution of this equation. So here b cannot be 0. So b we will equate with 0. How to find roots? So this is a. Here a is equals to 5 and b is equals to 3x minus 9. So in such cases, b we will equate with 0. So 3x minus 9 is equals to 0. So what we have to do? We have to equate b with 0. So b, when I'm equating with 0, I'll get the value of x is equals to 3. So that means root of this equation. Root means the solution is x is equals to 3. So that means what is the domain of this function? Domain of this function is equals to r minus root of this equation. What of root of this equation? That is 3. So domain of this function is r minus 3. Let's consider the next case. If fx is in this form, square root of a, then how to find domain? So then what we have to do? We have to equate a with 0. A is greater than equals to 0. Then domain is equals to the solution set of the inequality. A is greater than equals to 0. So how to find? Same thing we will do. First of all, we'll write a. A means that particular number which is written inside the root. So what is a here? 3x minus 9. The number which is written inside the root is a. We have to write this number is greater than equals to 0. This number is greater than equals to 0. So this inequation, this is not an equation, this is inequation because of this inequality. See, these signs are the signs of inequalities. Less than, greater than equals to, or less than equals to. These are the signs of inequality. Same way we have to simplify like equation. So 9 first of all we'll send to other side. So 3x is greater than equals to 9. Then x is greater than equals to 9 by 3. So x is greater than equals to 3. So we found the solution of the inequality. X is greater than equals to 3. Now what is domain of this function? According to the rule, what is domain of this function? The solution set of the inequality. The solution set. What is the solution set? Solution set is x is greater than equals to 3. So this is the domain of the function. So this can be written this way. It can be written in the form of interval also. So in the form of interval, if I have to write, so x is greater than equals to 3. So that means the least value or the minimum value of x is 3 and it is going till infinity. So this can also be written in this form. So we found out the domain of this function. Let's do the next one now. So if the function is given to us in this form, fx is equals to log a or fx is equals to natural log a, then how to find domain? This a we will equate with 0. A we will write, not equate, we'll write a is greater than 0. Since previous one, when it was square root, we wrote a is greater than equals to 0. There we took equality also. But here in case of log, we only have to take the inequality. So here for this function, what is the value of a? 3x minus 9. So whatever is written with log, so that is a. The argument of the log is a. So 3x minus 9. So this we have to write greater than 0. So if I write it greater than 0, I can solve this inequation. So after solving this inequation, same way like we did previously, I'll get x is greater than 3. X is greater than 3. Now domain of this function is what? Domain of this function is x is greater than 3. The solution set is this one only. So this can also be written in the form of interval. So 3 is the, see here equality is not there, this equality is not there, so that's why square bracket I'm not writing. So from 3 to infinity, from 3 to infinity, this is the domain of this function. Let's discuss the fifth one. So there are four cases we have discussed. First one was the when fx in the form of polynomial, when it is in the form of rational number. So a by b is nothing but rational number or fraction, you can say, when function is given to us in the form of a square root, then in the form of logarithm. And fifth one, it says when it's a combination of all, combination. So if it is a combination, so we have to find the subset of R. R means the set of real numbers, set of real numbers, and that will be the domain of the function. Like for example, for this one, these are the cases which we have discussed when the function is given to us in the form of square root. When the function is given to us in the form of a square root, a we have to write greater than equals to 0. So what is a for first one? For first one, we know a is x minus 1. So we have to write x minus 1 is greater than equals to 0. So from here we'll get x is greater than equals to positive 1. When minus 1 we shift to other side, it will become positive 1. For second one, a is 2 minus x. 2 minus x. So we have to write 2 minus x is greater than equals to 0. So now this inequation when I'm solving, so negative term, let's try to shift to other side so that we can avoid the negative sign with the variable, because some different rules are there for solving inequations. So here you have to be very careful. So 2 is greater than equals to x. When negative x I'm shifting to other side, it will become positive x. So or I can write x is less than equals to 2. X is less than equals to 2 we can write here. So I found two values of x. Let's combine both the values. So let's combine both the values. X is less than equals to 2 and x is greater than equals to 1. I've just combined both the values, and from here I got the domain of the function, that x is greater than equals to 1 and less than equals to 2. So this is the domain of the function. So x belongs to this interval. So here we have learned what is domain and range of the function, how to find domain and range of a function from graphs, and how to find domain of the functions when function is given to us in the form of a formula. In next few videos, we will be doing questions related to range and domain of the function. So thank you so much for watching. Like, share and subscribe.